All right, if you have not yet done this, for example, please pause the video now and work this next one out. It's very similar to the one we just did. When I move this paper, you'll see the answer. So pause the video first. And here are the answers to that problem. So hopefully all of this makes sense. We took the 0.07 for both in the middle, subtracted it out from the 48, subtracted it out from the 27, added those up, subtracted those out from 100 or from 1, and then we just straight up got our answers to those two questions. Let me know if you have questions about that. All right, moving on. Back in chapter 2, we looked at contingency tables, and in the first video I had mentioned those again, and we actually just drew one a few minutes ago. And we talked about conditional distributions. We had marginal, which was really for only one variable, and we had conditional. So we've used this word before, but now we're going to use it in a little bit more of a probability formal way. So first thing we have to do is we have to work on some symbols. When we want the probability of an event from a conditional distribution, we write the probability of B given A. And these are the symbols we use for this. This is how you say it. The probability of B given A. This little bar here means given. And this is a conditional probability. It means what's the probability of B, but only for the A group. What's the probability of B happens, but only knowing that A has already happened. So it's just like that conditional probability where we used to like zoom in on one line. That's kind of like knowing you're looking at a girl. What's the probability that grades are their favorite event or whatever this is. So that's what this symbol means. So don't be fooled into thinking we're doing something new. We've already been doing conditional percentages early on in chapter 2. Now we're just learning a different way of writing it. Okay? So find the following probabilities for each one of these. And so this is the same scenario we asked from chapter 2. We asked the kids what were they most interested in, their grades, being popular, or sports. And we also took into account their gender. So this means find the probability of someone from this set being a girl. And remember, probability is just simply the number of number of outcomes of being a girl. There are 251 girls out of the total 478. And so I could calculate that to a decimal if I wanted to. 251 divided by 478. And I get 0.53. We'll round that off to the 10th. All right, what's the probability of picking a person from this group and they're into sports? So that's just one variable. It's not conditional, so it's marginal. So you're going to use a marginal number, just like the other one. Sports total 90 out of 478. .19. All right, now we're getting into our conditional probabilities. This one, find the probability of picking a person from this group, because there's no condition, so we're talking about the whole group, marginal, and that person is a girl and popular. Girl and popular. Remember, it's not conditional, so it's still out of the whole group. So this time, I'm going into the margin, because into the insides, because it is two variables, girl and popular, but it's still out of the whole group. So it's going to be 91 out of 478. .19. Happens to be very similar just because the numerators are very similar. And now our conditional. Find the probability that we pick someone from this group that's in the sports, knowing that person is a girl. You know your person you're picking is a girl. So this is now conditional. It's conditional, it's a sports conditional on being a girl. So it's not just sports out of everyone, it's really just sports out of the girls. So now what we're going to do is we're going to look, this is going to zoom my eyes in on just this row. I'm only interested now in looking at girls. I know the person's not a boy, so we're going to take all the boys out. Now, what's the probability they like sports? That's 30 out of 251. We're not dividing by the total anymore. This is not anything new. We learned how to do this in the beginning in chapter 2. It's just this symbol is a little different, and now we're actually going to learn like a formula for this. But don't be fooled into thinking that this formula is something, it is new. We haven't seen it before in this class, but we already knew how to do this from earlier in the course, okay? Define the probability of the event A given the event B. We direct our attention to the outcomes only in B. So when you have a given, you only focus on the given group now. Just like when they gave me girl, I zoomed in on that line. We then find the fraction of those outcomes, A, that also occurred. So what this formula is the probability of A given B is equal to the probability of A and B over the probability of B. This formula is also on your formula sheet. It is the second formula on the right side. So kind of think about what this is telling you. Remember, we're focusing only on the B line. So we want not just the probability of A up here, because like for this one, sports would be this total number, but we don't want the boys anymore. So we're going to take the boys out because we know B has occurred. We know this person's a girl. So we don't want to count the boys. We just want to count the girls who like sports. That would be your A and B. And then out of B, out of the given, out of just 251, the girls. So the probability of sports, this would be done, the probability of sports and girls, that's the 30, over girls, 251. Note the probability of B cannot equal 0 since we know B has occurred.